Hello everyone. In this lecture, I shall discuss the dominance property to solve the game. So here there are higher order payoff matrix, and we don't have the we don't have the saddle point. Then we use the dominance rule to bring it to a 2x2 matrix. Okay. So if you recall our previous lectures, if there is a saddle point, then we have pair strategy. It is discussed in here lecture 1. In lecture 1 we have discussed it. Right. Now if there is no saddle point, but it is a case of 2x2 matrix, then we use mixed strategy. You can refer to my lecture number 2. Now for higher order matrix, right, you say it is a matrix of order m cross n, right, on payoff with there is no saddle point, then we use the dominance rule here, dominance property here. If by using the dominance property we will able to bring it to a matrix of order 2 cross 2, right, 2 cross 2, then we use mixed strategy case as we discussed in our lecture number 2, right. Now if we have, suppose here m cross 2 or 2 cross n, right, in that way we are getting, then in that case we use the graphical method, right, we use here the graphical method and graphical method use graphical method, you reduce to 2 cross 2 if possible, right. If not, if the method fails now, right, if this method fails here, then otherwise you use, so if it is failed, it fails, right, we use what, in case of method fails here, then we use here linear programming technique, LPP, right, linear programming problem technique, LPP technique, right, and we use the simplex method, right, we use the simplex method. So this is the idea. So now, before the details of the discussion of the dominance rule, let me to introduce myself, Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. Okay, so without much delay, let us now start with your dominance property. So coming to the dominance property, rule number 1, larger row dominant smaller row. Okay, so maybe more than one rows can be taken at a time, smaller. So what do you mean by that? So if you have the row Ri, if the elements of the ith row is larger than equal to the corresponding elements in a jth row, you say jth row in corresponding positions, right, in corresponding positions, okay, greater than equal to, then this Ri will dominate Rj, then Ri dominates Rj, and Rj is omitted, deleted. Rj is deleted. So this is the idea. Okay, this is the idea here. So for example, suppose you have a row like this. 4, 7, right, suppose the row is like this, 4, 7, 9, 3, 2, and 2, 6, 5, 2, 1, and 5, 3, 4, 9, 8, like this. You see here, if you compare here row 1 with row 2, right, this 4 is greater than 2, and 7 is greater than 6, 5 is greater than, so row 1 here is greater than or equal to, right, if it is 3 also, then also fine, equal also, okay, greater than is equal to R2, so here R2 will be omitted, okay, so here R2 will be R2 will be omitted. Okay, so this R2 will be removed now. So this is the idea. That means the larger row dominate the smaller row, right? And simultaneously it can also dominate simultaneously 2 or more rows. Looking into the case. Now coming to the second property. Now coming to the second property, smaller column dominates the larger column. So at a time we may also consider more than one column also. Okay, so that means if your Ci is smaller than is equal to Cj, right, means this Ci is the smaller row here, smaller column here. Ci is the smaller column here in corresponding positions. Then here Cj, the larger column is dominated here. Then Cj is dominated and removed, right, and removed. Likewise, the convex combinations of rows and columns also follow rule 1 and rule 2. What does it mean? That is to say, that means suppose here R1 plus R2 plus R3 divided by some 3, right, it is greater than is equal to here R4, right. So then this R4, this is larger here, so this 3 will dominate R4. R4 is dominated by R1, R2 and R3. So R4 is removed. Okay. Accordingly, if here column 1 plus column 2 plus column 3 plus column 4 divided by some 4. Okay, the smaller column will dominate, is smaller than some C5, right. So this is the smaller column. Okay, so this will be there and the larger column will be dominated. Then C5 is dominated, right. And suppose here C1 plus C2 divided by 2 is less than is equal to C3. Then this 2 will be there. Okay, this 2 will be there. This is dominated. C3 is dominated by C1 and C2. Okay, in that way we will see. That means the convex combination of row and column also follow rule 1 and rule 2. So I am just repeating again. Larger row will dominate the smaller row. Smaller column will dominate the larger column, and convex combinations of row and column also follow rule 1 and rule 2. Right. Now let us solve some important examples. So coming to a coin matching scheme, suppose A and B are 2 players, each having 3 coins, rupees 5, rupees 10 and rupees 20. Okay, that means we display the payoff matrix as follows. The payoff rupees 5, rupees 10, rupees 20, and it is 5, 10, 20. It is my player A is having strategy A1, A2, A3 say, and accordingly it is my player B having strategy, you say it is my B1, you say it is my B2, it is my B3, right. Then it is asked, if the sum is even, then A wins B's coin. So here you see, in this place 5 plus 5 is 10 is even, so A wins B's coin. B is 5, so it is plus 5. So now if the sum is in this position, it is 10 plus 10 here, it is 10 is even here. Okay, 20. So A wins B's coin. B coin is 10, so A wins 10 here. Similarly 20 plus 20, you see this place, it is 40 even, so A wins B's coin. B coin is 20, so it is plus 20. Now if the sum is odd, okay, you see 5 plus 10, 15, so 15 is odd, so B wins A's coin. A is 5, B wins means minus 5, right, B wins means minus 5, and 20 plus 5, 25, so B wins A's coin. Now it is 5 plus 10, 15 odd. Odd means B wins edge coin minus 10. It is 20 plus 10, 30 also. Here it is 20 plus 10, 30 here. So A wins here. A wins B's coin means 20 here, right? So now coming to this place. Here it is 5 plus 10, 25. So B wins A's coin. So it is here 10 plus 20, 30. So here A wins B's coin. B coin is 10 here. So this is the case. Okay. 5 minus 5 minus 5 minus 10, 10, 20 minus 20, 10 and 20. Now this is your player A. This is your player A. This is your player B. So now first we see whether there is any saddle point. We'll see here. Right. So in the row, in the first row, the row minima is 5 and 5. We star it. And in second row, the row minima is this. In third row, the row minima is minus 20. So now in the first column, the column maxima is plus 5. Second column, the column maxima is 10. Third column, the column maxima is 20. So we don't find any element having maximum value is equal to minimax value. So here what we see clearly maximum is not equal to minimax value. So there is no saddle point. There is no saddle point. Consequently there is no pure strategy, right? Pure strategy. However, it is a 3 cross 3 matrix. However, it is a 3 cross 3 matrix. So we use the dominance rule. To reduce the matrix as follows. So now you see here, if you compare your C2 and your C3, if you compare this. So here it is minus 5 minus 5. 10 is less than 20. 10 is less than 20. So C2 is smaller than. Comparing C2, comparing column 2 and column 3. Okay. Column elements in column 2 is smaller than equal to elements in column 3 in respective positions. So this implies clearly this. So this implies C2 dominates C3. The reduced matrix is what? Just you omit it now. Now this is now omitted. Okay, this is now omitted. So the reduced matrix is 5 minus 5, 5 minus 5 minus 10, 10 minus 10, 10, and it is here minus 20, 10, minus 20, 10. Okay, so it is here B1, B2, it is here A1, A2, A3. Now we think of the dominance here. If you compare these two here, right? So this minus 10 is superior to minus 20, and it is 10 is equal to 10. So here what you see? Here R2 you see, R2 row 2 is superior to row 3, right? Row 2 minus 10 is greater than minus 20. Okay, so here R3 will be R2 is larger here, so R3 is dominated. So this row will be now omitted. Thus the reduced matrix is given by here B1, B2 is there, A1, A2 is there. So now it is reduced. 5 minus 5 minus 10, 10. Now clearly it is a 2 cross 2 matrix. So here we apply the mixed strategy case, which is of the form A11, A12, A21, A22. So we consider the mixed strategy here, right? Consider the mixed strategy. Okay, so now we consider the 2 cross 2 matrix. It is being reduced now. Now the mixed strategy SA and SB for players A and B respectively. For SA, we have already here A3 is 0 here. A3 is omitted, so A3 is 0. For A1, it is the probability P1 and probability P2, and such that the sum of the probability is 1. Similarly, for SB, already here C3 is dominated here. C3 is dominated here. So we have C column 1 and column 2 means B1 and B2 having probability Q1 and Q2 such that the sum of the probability is 1. So now we apply the formula. So now this is the 2 cross 2 matrix. I write it of this form. So what is my let my lambda? Simply the formula. Lambda is equal to this plus this minus this plus this. A11 plus A22 minus A12 plus A21. Just you add it. It is 5 plus 10 minus, both are minus here, it is just 1 second. Okay, so this is minus of, again here minus 5 and minus 10, minus 5 minus 10. So it is here 30. The value of lambda is 30. So what is my value of the game? Value of the game here V is equal to this into this A11 into A22 minus A12 into A21 divided by lambda. Just you multiply it. 5 into 10, 50 minus plus minus. It is here minus 50 divided by 30. So value of the game here is 0. Okay. So value of the game is 0 means it is a zero sum game. Already 2 persons are there. Now coming to what is here P1. Here P1 will be equal to this minus this means A22 minus A21 divided by lambda, right? So it is here 10 minus of minus 10 by 30 is 20 by 30 is here 2 by 3. So this implies what is here P2 is 1 minus P1 is 1 minus 2 by 3 is 1 by 3. Okay. Similarly, what is here Q1? And Q1 is equal to this minus this A22 minus A12 by lambda. So this is equal to 10 minus 5 by 30 is 15 by 30 is equal to here half. So this implies here Q2 is equal to also 1 minus Q1 is half. Hence, thus the mixed strategies are SA is here A1, A2, A3 is A1 is 2 by 3, A2 is 1 by 3 and it is 0. And SB is B1, B2, B3, it is already 0, it is half and half. Okay. With value of the game, V is equal to 0. Thus the mixed strategies are, okay, this is for player A and it is for player B. Okay, so this is your answer. Now let us solve one more example so that your idea will clear. So coming to this problem, so this is a 5 cross 6 matrix here. Also there is no saddle point, you can check it. So now you see, if you compare row 1 and row 2 here, so row 2 is superior. Okay, row 2 is larger than row 1. Row 2 is larger than row 1. And if you compare row 4 and row 5 at the same time, right, row 4 and row 5, four, 3, 1, 3, 2, 2, So I am repeating again. So your R2 is superior to R1, right? So R1 is dominated, R4 is superior to R5, so R5 is dominated. So removing row 1 and row 5, we have this is the reduced matrix. Now we compare the columns here. Okay, you compare the columns here. You see your column 5. Your column 5 is smaller than 6, is not it? Column 5 as column 5 is smaller than column 6, and also your column 5 is smaller than also C1, also C2, column 5 is smaller than C2, and column 5, okay, column 5 is smaller than C6, C1 and C2, right? So these three things will be dominated by C1. So it will be there. It is dominated, it is dominated, and it is dominated. So it is removed. So it is removed here, right? So these three will be removed as this. So C5, this C5 will be there. Dominates here C1, C2 and C6. Thus the reduced matrix is given by so now this is the reduced matrix. Now you compare it. Here now, if you find the average of these two, right, average of these two as column 1 plus column 2 by 2. So here it is 4 by 2, here it is 2, here it is 1.5. So it is smaller than your column 3, right, smaller than your column 3, right? So column 3 is the larger column, will be dominated. C3 is dominated, so this is dominated. So this is the, as I have told, the third property, convex combination. So C3 is dominated. Thus the reduced matrix is, you see here, it is B3, B4, and it is A2, A3, A4. Okay, this is 1, 3, 7 minus 5, 4 minus 1. Next we see the row reduction. Next you see, if you find the average of these two row, right, next as R1 plus R2 by 2, okay, it is 8 by 2, 4, it is also minus 1, means same, okay, same, or I can write it R3, or I can write it greater than equal to, okay, since equality is there, means your larger row will dominate the smaller row. So this R3 will be dominated, so row 3 will be dominated, right? So R3 is dominated. Consequently, the reduced 2 cross 2 pair of matrix is as follows. So what is the reduced matrix? Here 1, 3, 7 minus 5. It is my A2, A3. It is my B3, B4. Let it be resemblance with A11, A12, A21, A22. So now it is a 2 cross 2 payoff. So as usual we apply the formula. Okay. So coming to the formula, what is my value of the game? The value of the game, let first year lambda is equal to this plus this minus this plus this. A11 plus A22 minus A12 plus A21. Okay. So this is 1 minus 5 minus 7 plus 3. So this is equal. So this is minus 4 minus 10 is minus 14. Okay. So let you first declare the mixed strategy. Consider the mixed strategy. For A and B as SA and SB respectively with, what is your SA? SA is A1, A2, A3, A4, A5, and your SB is B1, B2, B3, B4, B5, B6, and the availability here is A1 and A2 and A3. So A2 will be your P1, A3 will be P2, remaining are omitted, so this probability is 0 here. For B similarly you have B3 and B4. B3 it is Q1 and it is Q2, rest are 0. Okay, such that here P1 plus P2 is equal to 1 and Q1 plus Q2 is equal to 1. So let us now compute the all other parameters, lambda, value of the game, P1, P2, Q1, Q2 and so on. So now coming to your P1. Now your P1 is equal to, now first you come to the value of the game, okay. The value of the game is, coming to the value of the game, V is equal to your A11 into A22 minus A12 into A21 divided by your lambda. So if you simplify it, it will be your 1 into minus 5 minus 3 into 7 divided by lambda. So that is equal to minus 26 by minus 14. So this is equal to 13 by 7. So my value of the game is 13 by 7. What is your P1? P1 is equal to A22 minus A21 by lambda. So this is equal to minus 5 minus 7 by minus 14. Here lambda we got it minus 14. So this is 12 by 14 is 6 by 7. So this implies your P2 is 1 minus P1 is 1 minus 6 by 7 is 1 by 7. So next, what is your Q1? Your Q1 will be this minus this. A22 minus A12 by lambda. So it is minus 5 minus 3 by lambda is your minus 14. So this is your 8 by 14 is 4 by 7. So this implies your Q2 is 1 minus 4 by 7 is 3 by 7. So all the parameters are obtained. Hence the mixed strategy SA and SB for A and B respectively are your SA, your A1, A2, A3, A4, A5. Already this is 0, this is 0 and this is 0. You got it 6 by 7 and this is 1 by 7 and your for SB is, and for your SB is B1, B2, B3, here B4, B5, B6. This is already 0, 0. This is 0, 0. 3 and 4 are there only. 3 and 4. And Q1 is 4 by 7. 4 by 7 and 3 by 7 with value of the game. With value of the game. V is equal to, we got it. Here V is 13 by 7. 13 by 7. So this is your answer. Okay. So this is all about the your dominance rule, right? So dominance rule is very important to solving many problems, but the difficulty is there by dominance rule in some cases. Suppose we reach at some 2 by n, or we reach at some m by 2, right? Some m by 2. Then in such case, okay, and it further is not reduced to 2 cross 2. Then for in this both cases we use here the graphical method. Okay, here we use the graphical method, right? And the problem if not solvable by any of these methods, then or else we use, otherwise we have to see the LPP technique, and the simplex method. Okay. So in my subsequent video, I will discuss this 2 cross n m cross 2 followed by the simplex method. So with this, my appeal to all of you, if you feel this lecture is interesting and helpful, please like and subscribe to this channel, which will boost my motivation. As a result, it will motivate me to upload the subsequent videos for your benefits. With this, let us close this lecture. So thank you all. Have a nice day.